Chapter 7, Section 4 is the applications of normal distributions. That will be Austin's chair you just heard. To solve problems by using the standard normal distribution, transform the original variable into a standard normal variable by using the formula that I gave you yesterday, and it's also here on the screen. We have z equal to the value, subtract the mean, divided by the standard deviation. You can see here in words and here in symbols. So in this problem, we have if the scores for the test have a mean of 100 and a standard deviation of 15, find the percentage of scores that will fall below 112. First thing we need to do is draw our graph of the normal distribution and try to move it down. There we go. And we're going to plot on here what we have. We know our mean is 100. So this line here must be 100. We also know we're looking at the scores of 112. We want to know, what do we want to know? We want to know the percentage of scores that will fall below. So we're looking at anything below 112, which is to the left. Right? So to find this, we need to look at what our z value is going to be. So we know z is going to be our mean, and we'll cross that z for Elise. So we have our value and our mean, so our value is 112. And we subtract our mean, which is 100. Then we divide by our standard deviation, which is 15 in this case. So we calculate this out. We find out that 112 subtract 100 gives us 2 over 15, which our handy dandy calculations come out to 12 divided by 15, which comes out to 0.8. So we're looking for when z equals 0.8. Our z value for 0.8 is 0.2881. Remember, that is from the mean to our point. So this area here is 2.81, and we have this extra area over here still that we need to look at. How much is half of it? Half of it is going to be 0.5 or 50%. So we add these up. We say 0.2881 plus 0.5. And we get 0.7881, which yields 78.81% of the people have a percentage below 112. And here's the next problem. Each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the standard deviation is 2 pounds. If a household is selected at random, find the probability of it generating between 27 and 31 pounds per month. So the first thing we need to do is to get up our beautiful normal distribution. Put it over here to give myself more room. And we need to write in what we're working with. So we know that the average, the mean of the household, is 28 pounds. So our mean is going to be 28. And we need to look, generating between 27 and 31 pounds. 27 pounds would be on this side here, less than 28. Well, let's try not doing it awfully like that. And fold, straight line. There you go, straight lines, guys. So there's 27, and we have another straight line for 31. So we're looking at the area between these two here. When we're looking for between, we know we have to add it up. But first we need to find our z values. So remember that our z value is going to be equal to our value, 27 minus 28, which is the mean, divided by the standard deviation of 2 pounds. And for the other one, we have a z value is equal to 31 subtract 28 divided by our standard deviation of 2. And I want to print, I want to pause. So we have 27 subtract 28. We get this side's equal to negative 0.5 or negative 1/2. And this one here is equal to 3/2, which is 1.5 standard deviations. When we look these z-scores up in the back of the book, we get, so when we're looking up negative 0.5, we know we can look up negative 0.5 and get the same, or we can look up 0.5 and get the same value. So at 0.5, we get 19.15%. And for 1.5, we get 43.32%. Now with these two, we know we have to add them because one is on the left side of the mean and one is on the right side of the mean. So we add up these two numbers and we get, when we add these together, 62.47%, which is the total shaded area. The part I'm underlining in red was this piece here. The part underlined in green was this piece here. And we added them together. So 62.47% of households in America will generate between 27 and 31 pounds of newspaper per month. So the next problem we have, each month, an American household generates an average of 28 pounds of newspaper, garbage, or recycling. Assume that the standard deviation is 2 pounds still. If a household is selected at random, find the probability of it generating 30.2 pounds per month. So again, we write in our mean. Our mean is 28, and that is our center line. Then we need to write in where we're going to. We have 30.2. So right here we have 30.2. We're looking at finding out how many people generate more than 30.2. So to be more than 30.2, we're over here. So for this one, I'm looking at this part here. Remember from yesterday, we need to find the z value for this, and then we need to subtract the percentage for this piece here, which I'll color for you guys in green. We're going to subtract this piece from the whole half. The whole half, again, remember, is 50%. So we look at this and we have to find our z value. Our z value is going to be equal to our value, 30.2, subtract 28, and we're going to divide by our standard deviation. Our standard deviation, again, is 2 pounds. So we calculate this, and we get 2.2 divided by 2, which gives us 1.1. When we look up 1.1 on our table, we find out that 1.1 is equal to 36.43%. Remember that this is our green section, and we don't want the green, we want the red. So we have to take our 50%, which is the whole right side, and subtract our 36.43%. When we do this, we get 13.57%. So the percent of American households that generate 30.2 pounds per month or more is 13.57%. The next problem we're looking at says, in order to qualify for a police academy, candidates must score in the top 10% on a general abilities test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. To do this, we need to make sure we have our graph. So let's paste that in there. And moving the graph over. When we move the graph over, we can slide it here. Okay, and we need to work backwards to do this. So we're looking at the top 10%, which we know we have 50% on this side of the mean. So we know 10% is going to be down here somewhere. 10%. We'll color in what part is 10%, which is right here, the very tail end. Now, to get our number that we need to look at how far away from the mean are we? If we're at 10%, what percentage is here? Well, we know this whole side is 50%, so the percentage we're looking at in red is 40%. Now we have to look for the z-value. That'll be 40%. If you look it up in the back of the book, there is not a z-value that is exactly 0.4000. What we do find, though, is 0.3997, which is the closest. Sorry, Austin, I made you look for 40% today. This works as well. So we're here at 0.3997, and its z-value that goes with it is equal to 1.28. So we know that from the mean, 40% of the data is 1.28 standard deviations away. But we don't care about that z-value. What we do care about is what the actual value is. So remember in the formula we have the actual value. I'm going to put an x here. Subtract our mean, which was 200, and I didn't write it on the graph, so let's write that on now. So x minus 200 divided by our standard deviation, which was 20. Sorry, I misspoke before when I called this a standard deviation. It is a z-value. So when we multiply that out, 20 times 1.28 is equal to 25.6. And then we have x minus 200 on the other side. If we add 200 to both sides, we end up with the equation x equals 225.6. So to answer the question, the lowest possible score to qualify for the police academy would be 225.6. We had to work backwards, remember, finding our percentages first, and then going from our z-value into what our actual value is. So we see that z times our standard deviation plus our mean is equal to our x value that we were looking for. So when you worked backwards, if we had solved the formula first, we would see this formula here, and we could just substitute in to solve it, where z was equal to 1.28, our standard deviation was 20, and our mean was 200. Doing the workout, you will get the same answer of 225 I don't remember what it was, 0.6, which we can round up to 226 altogether for a nice rounded score. So that is all for this section. Have fun tonight.